In this video, we are going to put everything together we've learned in the past couple of videos about asymptotes and domain, along with some other rules, and actually do complete graphs of rational functions. This right here is your listing of your steps for graphing a rational function. Number one, you want to check to see if the graph has any symmetry. If there is any y-axis symmetry, then f of negative x equals f of x. This is the same as saying that the function is even. I don't know if you recall that or not, but that's how you know if a function is even. It will have y-axis symmetry. There is symmetry to the origin if f of negative x equals negative f of x, and I will show you in detail on the next screen how you check for this. Number two, find and plot the y-intercepts by evaluating f of 0. There might not be a y-intercept. Number three, set the numerator equal to 0, factor if necessary, and solve. This is going to give you the x-intercepts, and then you plot them. Set the denominator equal to 0 and solve. This is going to give you your vertical asymptotes. Find any horizontal asymptotes by using the rules from the previous video comparing the degree of the numerator and denominator. And then to flesh out your picture, you need to plot at least 1 point between and 1 point beyond each x-intercept and each vertical asymptote. And then use smooth curves to complete the graph beyond and between the vertical asymptotes. And that is all there is to it. So stop the video if you need to copy all these down if you have not gotten these in class. So let's do an example and see what's happening. Here's our list of things we're going to do. Here's our function, f of x equals 2x minus 1 over x minus 1. So number one, we're going to check for symmetry. To check for symmetry, we're going to do f of negative x. And what f of negative x means is plug in negative x in for x in the original function. So in this position, and this position, I have put in a negative x. And then I'm going to work that out. If I multiply here, I get negative 2x minus 1. This just removes the parentheses, and I get this denominator. Are these two things equal? And the answer is no. So there is no y-axis symmetry. So let's also check for symmetry to the origin. To check that, I'm going to have to see if these two things are the same. So negative f of x just means to negate the original function. So I just put a negative sign in front of the original function. Notice that negative sign just goes right smack even with the line. The negative in front of a fraction means the negative could be distributed to the top or the bottom, not both. I choose to distribute it to the top, and now this is what I'm comparing these two. Are these two things exactly the same? No, that means there is no symmetry. So that brings us to the y-intercept. To do the y-intercept, we're going to evaluate f of 0. What f of 0 means to do is go to the original function and put 0 in for each of the x's, which is what's shown right here. Working this out, 2 times 0 is 0, minus 1 is negative 1. 0 minus 1 is negative 1. Divide that out and you get 1. So you do have a y-intercept at 1. X-intercept. We're going to set the numerator equal to 0 and solve. The numerator is this right here. So we're just going to set 2x minus 1 equal to 0. Go through your simple algebra steps to solve, and I end up with an x-intercept of a half. Now, I will write all this for you on another screen where we get ready to do the graphing. This is just showing you step by step how to find each particular piece of information. Brings us to vertical asymptote. You want to set the denominator equal to 0 and solve. The denominator was x minus 1. Solve that, we get x equal 1. That's our vertical asymptote. Check out your horizontal asymptote situation. You're going to check the degree of the numerator and the denominator. There was our original function. I penciled in a 1 for that coefficient. We know if these two degrees are the same, then all we have to do is look at their coefficients. So it is the ratio of 2 over 1, which is just 2. So this gives me all of the information. This is what we found on the previous screens. There was no symmetry. The y-intercept was 1. The x-intercept was a half. And here are the asymptotes. And the asymptotes for you. We have a horizontal asymptote at y equal 2. We have a vertical asymptote at x equals 1. Now these two asymptotes chop this grid into 4 locations. And you know from looking at the graphs we did with the calculator that we're going to get some sort of curve. But are the curves here and here? Or are they here and here? Potentially they could be next to each other here and here. So we have to decide where they go. And we're going to be able to do that very easily with some extra information here. We have a y-intercept of 1. So on the y-axis, I put a dot. We have an x-intercept of a half. Well, that's halfway between 0 and 1. So I have an x-intercept right there. That tells me that one of my curves runs just like this, goes through that intercept, hits that x-intercept, and comes on down. I can verify that by doing some arithmetic in a t-chart, and I will, but that's what the intercepts tell me. And you'll get more comfortable with doing that after you practice a lot of these. Now, I have to decide, is the other curve here? Because that's a possibility. However, if it went like this, that would mean we had another x-intercept, which we don't have. That tells me it can't do that. So I'm pretty sure it's going to go up here, but I'm going to verify by doing the arithmetic. If I plug 2 in here, 2 times 2 is 4, minus 1 is 3, over. Put a 2 in the bottom, 2 minus 1 is 1. So that means the point over 2 up 3 is in my graph, which verifies what I thought a minute ago, and that was the curve did this. We'll do some more arithmetic just to see. Put 3 in here. 2 times 3 is 6, minus 1 is 5. 3 in the bottom, 3 minus 1 is 2. So the point over 3 up 5 halves, which is the same as 2 1/2, is on my graph. So over 3 up 2 1/2, see how this is going to curve down like this. So this is going to be the other part of my curve. I could plug this in just to show you that I was right about what was happening over here. So let's put -1 in over here. 2 times -1 is -2, minus 1 is -3. Put -1 in the bottom, -1 minus 1 is -2. Of course, a negative divided by a negative is a positive. So that's the point -1, 3 halves, which is the same as -1 up 1 1/2. Bingo, right there. So this is what my graph looks like. Now, it is possible for a graph to cross a horizontal asymptote. How can we tell that without having to do a bunch of points in the t-chart? Go back to my picture here. I just knew that it didn't cross the asymptotes. But one reason I knew is because I'd already graphed it on a calculator, and you're not going to have that luxury when you're taking a test. So you're going to have to know if it's going to cross the asymptote. One long way to do it is keep putting numbers in. Put 4 in, put 5 in, put 6 in, put 7 in. But that's a hassle. It might cross the asymptote way down here. So there is a way to tell if it crosses the horizontal asymptote. So first off, it is possible for the graph to cross the horizontal asymptote. All we have to do to tell if it does is set the function equal to the horizontal asymptote and solve. Our horizontal asymptote was the line y equals 2. So here was my function. I set it equal to 2. I want to think of 2 as 2 over 1. All I have to do here is cross multiply. Solve by subtracting 2x from both sides is going to make that go away, and I'm looking at -1 equals -2. It does not. If you think back to your basic algebra, if the variable disappears and you are left with a false statement, then that means this is empty set. There is no solution to this equation. If there is no solution to this equation, that means the curve does not cross the horizontal asymptote. So that's how you'll know. So from now on, once you have your horizontal asymptote, right then you are going to check to see if it's going to be crossed by the curve. One last thing on this video, go back to this t-chart. You might have wondered where these numbers came from. These are the numbers that are beyond my x-intercept or beyond my vertical asymptote. My vertical asymptote was here at x equal 1, so it made sense to put in 2 and put in 3 to see what was happening over here. The -1 and the -2 are because they are on the other side of my y-intercept. I wanted to verify that it really did curve up towards that asymptote. The next couple videos will have a few more examples of these.